try and get those done in maybe, I don't know, we'll see what fits. Alright, so I didn't want to make a complete fool of myself this morning, but I really wanted to just walk you through something that's kind of important to me. If you get the table of integrals, the table of integrals, and I'm going to go on with the vector stuff this morning, but I just want to do this as a one. So if you get the table of intervals and you get something like this, I don't know why it's on such an angle. Square root of, I don't know, what are we going to put here? X. Well, I should look them up. That would be a smart thing to do, wouldn't it? So I'm looking for an equation sheet. Sorry for the little pause here. Let's try that. Let's go to this one. And you'll learn about this a bit later on, but yeah, I might just sorry, just don't want to get off the theme of implicit differentiating expressions just at the moment, because I hit it pretty hard last week, and I want to do the vector stuff with you because I know that's the pressing problem that you've got. Now, just in terms of the subject, do they put with the assessments? Are the first assessments, was it a general one, or have they jumped straight into vectors?
They gave us like a practice one last week, like a quiz zero, so to speak.
So that's like
Um,
indices and all that
yeah,
kind.
yeah,
Yeah.
yeah,
Okay. All right.
yeah,
Okay.
just some basic stuff.
All right. So I don't.
And yeah,
Okay. So I don't need to stress too much about getting out of sync with, you know, that stuff. So that's fine. All right. So I just want to get to this. Sorry, it's just going to take me a moment to pour through the thing that I want. And just when you go to put your hand on something, it disappears. So that's kind of what's happened to me on this occasion. Something's just disappeared on me. So this particular subject has changed so many times over the years. It's amazing how many times it's changed. We want to get to 5. Yeah, that's good. 8. Okay. So we go here. Sorry guys, I just have, like, I'll tell you what the pause is. I'll tell you why I'm being such an annoying dude at the moment, is that I've got so many things here that I have for my practical parts. So I've just been looking up here because I've been doing the latest ones up here, and in this one here, now these are older now, so they're not so quite where I want them to be, but basically that's what I'm doing. I'm just finding something for you. And remember, this is a bit ad hoc for me as well, and I don't mind that because you get so much formal stuff happening. The only danger I've got to be sure of that I'm not wasting your time. So, but I kind of am, because I want you to you know, it's much about how to study, but some of you will already know that. And okay, so let's have a think about this one. And I know that you'll be doing some of this anyway. I just wanted to get the right integration table. Dear, oh dear. Let's have a look at this. Okay, so yeah, alright, that's the one I'll pick. One of those. Alright, so this sine to the -1 up here. Alright, so all I'm doing is just kind of thinking about maths. I haven't dropped it off completely. And so we're thinking about that one. So I might just pull that over there. And let that just sit a bit smaller. And what's the idea of going to the integration tables? We haven't done integration. We're doing, you know, vectors, you idiot. We've just done a little bit of a test, so we just want a little bit of help with that stuff. But again, this is the informal course. It's the way of us just exploring ideas together, and I'll answer your questions, there's no question about that. But let's try this. Let's see how close we can get to it. And let's go for something like y equals cos to the -1 x. Let's think about what that looks like for a moment, because the big thing I'm doing here is undo, which is what we did last week, right? So the big thing is undo. So one of these is going to fall out fairly readily for me, and one of them is not. So we'll just see which one we're going to go with. I might do two like this. Alright, so when you're faced with a problem like this, and it says, you know, d dx this, so one of the things that we can do with d dxing expressions is that we can find for ourselves the answer just by simply using the tools that we introduced last week. So if I were going to do this one of the things that happens in maths is that you don't always get the obvious thing. So undo here is the answer. Recognizing that you have to do undo, okay, is really important. So here we're going to go through with sine y. Well, that's not undo, but look at this. Oh, what's happening there? That is undo. So what we get is we get sine y equals x. Okay, so a variation of the thing there. I'll get this one right at some point, but for now we'll just go with this. So what we're going to do is we're going to d dx this. Well, hang on a minute, how do you d dx a sine y? Well, this is where the chain rule comes in. So the way I would do this is I'd say let's do a d dx. Now that's the expression idea. So if anyone hasn't seen last week, this is a real annoyance. This is a typical lecture type problem of being involved in something that you don't recognize, which is what I'm trying to avoid for all of you. But the point is, if you've watched last week's video, we did do d dx expressions. The variation this week is that we're not only doing d dx expressions on x, we're going to do it on y. And the beauty of this is so easy because we know the chain rule. So I'm using the basic chain rule and the d dx expression version, okay, to get this out. So what we do is we pick up the expressions this way and we write them term by term. So it's a bit like distributing d dx across the brackets, okay? And then what we've got to recognize is, well, d dx of x, that's pretty easy. That's pretty easy. That's an expression. You see that? That's exactly what we did. So if y was equal to x, and then I said differentiate y equals x, or find the derivative, or whatever you'd like, you'd be pretty good at going like this, wouldn't you? Okay, the one would come out the front, and you'd 1 off 1, so you get 1 times x is 0, which would be 1, which would just leave you with 1. Okay, so you'd be pretty happy with that whole idea. Here, I can just straight away see that I'm ddxing, so I'm doing the expression version, and I'm just writing a 1. Well, how do I do this? This is ridiculous. ddx sine y. Well, I want the chain rule. I'm still going to have ddx. There you go. But we're going to go through something else. What's the something else that would make sense here, anyone? What's the something else that would make sense? We've got a variable y, haven't we? So the thing that we're looking to do is to put in the chain rule dy dx. Okay. Very good. Now the thing about this one is, now this is quite a heavy load, this question, so I don't expect you to get it today, and it's not preparing you for a test in the next 3 or 4 weeks. The purpose of this is to expose you to an application so that you can think about it over time. So in a month's time you can look back over this and go, this makes perfect sense now. Okay, so I'm not worried about if today's it's a bit lost on you. And remember, we're only going to do this for about half an hour, 35 minutes, and then I'll get back to vectors for you, because I know you're keen to make sure that you're current, and we need this to be current as well. Alright, so now this makes more sense. What's the dy? That's the expression term, isn't it? See, it keeps popping up. Now if you have had no experience with expression differentiation, I may as well be talking some other language, Martian language. Okay, but now what I'm trying to impress on you is that, especially from last week where we swap between one form and the other, this is what you've got to do here. Okay, so what is the differential of sine? And also, remember, you can cheat, right? You can do that. And then you can go steep positives. Mark them off. Steep positives, starts up here, goes to 0. This is your M curve, and then it starts going negative to its steepest point there, so that's that point, and then back up. What curve is that? Okay, so the dy of sine y is cos y. Now we keep this dy dx equals 1. Now what am I doing? Does anybody have any experience with this, with 4 unit or anything like that? Because 4 unit students learn what I've done here. This is an example of implicit differentiation. Mary will teach you this, but I'm not teaching you implicit. I know that seems like a long bow to draw. What I'm teaching you is the core skills. In this case, it's trig coming up, but it's also expression differentiation. The valuing of things is why we fumble and stall a little bit with maths, isn't it? Because we don't value them and we kind of drop off in disinterest. But we don't want that, we want to revalue. So implicit, a good example is when you can't get it strictly in terms of. So what you've learned all the way along is an explicit differentiation. So you've got x in terms of y. So when you come to do this, you can do the easy bit. Now what happens if you get an expression where it's not simple to put the expression in terms of x or y? Now you could say, oh yeah, but we could square that. But I could use any kind of thing, couldn't I? To say, how would we get it explicitly? So it's quite difficult. Okay, it's quite difficult for some examples. Alright, I don't want to labour that too much because that's just experimenting with figures. So the idea here is, so that's a 4 unit topic. It's tucked away in the extension 2 syllabus, but it is there, implicit differentiation. And Mary will teach you that. And she'll do better examples than what I'm doing here. But I wanted to do something here that related to this stuff, because the question at the beginning of the show was, what's the point? Alright, so what we're going to do here is we're just going to divide by cos y, and so we'll get cos y over cos y dy dx. That's another form of 1, and 1 over cos y. So that's effectively gone. Okay, so I'm going to move this down here now, and what we're going to have is dy dx over cos y. Now, interestingly, so much of what you do builds and builds, because it's a spiral curriculum from school, right? And you revisit stuff, and often if you don't get it in the first place, it's really hard to kind of solve. Okay, so remember we started out by asking the question, d dx this stuff. Okay, find the derivative. And these are inverse. And so what I'm trying to do is just clue you into all the little things that go together to unpack this. On one level, I couldn't care less about this because it's not central and important, but it does explain this. Okay, and the skills that you need are the things that are important to me that they're not missing. And the skills in the first instance are we're doing expression, differentiation, we're doing undo. See those themes? They don't go away, they're always there. Undo, expression, differentiation, and now we've got to do some exact values trig. Well, where does the exact values trig come in? Up here we had an expression after we'd done all of the bits, sine y equals x. So we're going to take that down here, and we're going to remember that we had sine y equals x. Okay, and we're going to remember that. Alright, the next thing we're going to do is that's the differential. That's dy dx. It looks nothing like anything over here. Okay, so we need to do a bit more work. You wouldn't be wrong in saying the dy dx of the inverse of sine to the minus 1x is 1 over cos y. You would not be wrong in doing that. You'd be completely right. However, it's not in terms of x, and we need to put it in terms of x. So we go back to last week where we did this one. Who remembers this? So 1 squared is equal to x squared plus y squared. What's the association for x? X is cos squared. And y was? What's a new name for y?
Sine.
Sine squared. Okay, so I'm not putting the variable in, I'm just leaving it out just for a bit of fun. Now after this guy, cos, and I've got this guy as well, so let's just see what we can do here. Maybe if I square this, what happens if I square this? I'll get sine squared y is equal to x squared, provided we do both sides. That's a valid thing to do. Now look at that, we've got a sine. How good is that? We're after cos, so we need to rearrange this. So what I'll do is I'll minus the sine, so I'll get minus, better take the long way here so people don't get fully frustrated with me. Okay, and so what we've got is 1 minus sine squared equals cos squared. And the next thing we're going to do is take the square of both sides, or rearrange it, you buffhead. Make it so that it's all on the nice side. Who can see what's happening? And then I did this when I did the anticipating the quadratic formula. Do you remember when I did completing the square on the general form? Who can see what's happening? Is I love saying that. I don't know why, it makes me such an idiot. So if I take the square root of both of these, what I'll get is the positive one. Oh, look at this. Who can see what the next step is? There's my cos. I've got my cos. Alright. What else can I do? What else can I do? The sine. Look. I've got a new thing of sine. I've got sine in terms of x. And I just took that from when the result of undo. The result of undo was this thing that I'm using. I borrowed this. So I haven't changed anything. Everything's not been changed and we're still cooking. So what I'm going to write here is cos whatever is 1 minus sine y is x squared. So I can put whatever in as y. Oh, look. 1 over dun, 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 dun. Wow. Okay. So if you like, what I can say up here is that sine to the minus 1x plus c, now this is where I'm getting a bit nerdy, alright, sine to the minus 1x plus c, sine to the minus 1, which was asked to differentiate, sine to the minus 1x plus c is equal to the integral of 1, oh you guys are so smart, dx. Okay, so we've made a version of the integration tables. They come from somewhere, folks. And in your maths experience here at UTS, you're learning the ins and outs of where this stuff comes from. This is the horsepower that separates you. Okay, this is why I'm encouraging you so much and spending so much time on you, because I used to be an engineering manager, and one of the things that I would do is employ a graduate recruitment program for the corporation that which was hundreds of millions of dollars worth of corporation. And in interviewing the people who just graduated from uni with their engineering degrees, wanted to come into the business, one of the things that will crop up is the maths. How can you handle your maths? And often you get this, you go, oh well, I graduated, I'm pretty good. It's like trying to tell me that, and straight away I know, oh, okay. So if you want to differentiate yourself, befriend maths. This is a unique opportunity to have a know-how session like this with an academic and trying to understand how maths works in your favour. A very basic idea, a statement of that, which is sometimes what I used to tell Year 12 students, was let's kick maths rather than maths kicking us. Alright, so let's be the ones where instead of maths kicking us, we're kicking it. Now that can be modified, that question can be modified. The original one, ddx y equals sine to the minus 1 x on a, that can be modified like that. Now you could go through and repeat this process for practice sake to show what the output, whether or not you get this one. Would you get this one? Okay, so I'm happy for you to go away and try that and then come back to me and say, look, I got so far but then I kind of got stuck. And there is actually a nasty algebraic trick that you need to do with brackets. So if I just do that now, just as a little aside, which you may not have seen. So if you get something like, you get x outside of 1 minus x, that's horrible. That's horrible to deal with. So what we know is with the indice laws, we can't do anything with that the way they are. But what we can do is we can take x squared and take the square root. What's the square root of x squared? It's x, isn't it? So now we've got a product. So when we get a product of anything, okay, we can do 8 product 2. Now we can put them inside. Okay, so because of this minus here, this is algebra like, this is what I would have your first test as, just these bits. Okay, you can put it inside, but you need to do x squared bracket 1 minus x squared. Okay, now if that's an a, I've been a bit cheeky putting an a, but if that's an a, then this would be a squared, this would be a squared, that would be a squared. And you can see what's going to happen when you do the expansion. You're going to get a squared minus a squared x squared over a squared. They're going to cancel, aren't they? And then you're left with a squared over x squared. Now you wouldn't have learnt that at uni, at school. You did learn this, but it might not be apparent to you. And that's the purpose of these sessions, for you guys to come to me and say, Jason, I don't understand how they got that. Alright, so I'm really happy for you to do that. This is the place to do it. Alright, it's for you to come and say. So now you can see a squared, oh there it is there, look, a squared minus x squared, cool. Okay, so the form of the original question would be slightly different to get that little happening thing happening. But anyway, I'll leave you to explore that. But the basic essence is, what did we need from assumed knowledge? We needed undo. Okay, so we needed undo. We needed expression differentiation to do implicit. Expression differentiation. And then we needed exact values tree, straight off the sheets from last week. We needed those three things in order to implicitly differentiate. So when you encounter implicit differentiation with Mary, you'll be looking out for expression differentiation, you'll be looking out for undo, and you'll be looking out for exact values trig, and you'll be expecting it. And right now you might be sitting there going, oh gee, okay, but you've got time. The point is you've got time. Okay, you can do this. This is not beyond you at all. All right, are there any questions about what I've said and done there? Are you happy for me to keep going? Has anybody else got any thoughts or queries of their own? Okay. All right, so what I might do is I might just break that off into a different video, and so I'll just stop the video.